Introduction. Double-rotted differential leveling is a method of determining the difference in elevation between points by employing two routes simultaneously. Two turning points are established such that at each setup of the leveling instrument, two sets of independent backsight and foresights are taken.
Employing double-rotted differential leveling provides a continuous check on the process of determining ground elevation while the work is in progress. The method is also useful when there is an urgent need to undertake differential leveling in a short period of time, where no established benchmarks are available for checking results. The objectives of this fieldwork is to acquire and develop the skill of determining the vertical distance, elevation, and height of a remote point by applying trigonometric and related analysis, and to develop the skills of reading vertical angles using theodolite.
Instruments that are needed: theodolite, leveling rod, markers, chalk or marking pins, measuring tape, plumb bob, and range pole. First procedure: set up the theodolite at a convenient location and call it point A, where the leveling rod and the remote point are visible. Using the telescope, take sight at the topmost remote point, then read the vertical angle, and record as alpha on Table 5 Trigonometric Leveling. Take another sight for the second trial. This is done to determine the precision of the observations. Calculate the mean of the two vertical angles or the angle of elevation of the specified point from the station. Set the leveling stop or rod vertically near the base of the remote point and take the level foresight on the road to determine the height of the instrument. Transfer the instrument level towards the location of the remote point and designate it as Station B, then measure its distance by taping from its initial position. Record this as distance AB. After centering the bubble of the instrument level, sight at the same topmost remote point twice using the telescope, and record as beta on Table 5 Trigonometric Leveling. After recording these two observations of the vertical angle, calculate the mean. Level the telescope while at B and get the height of the instrument by sighting the same leveling rod near the base of the remote point. Analyze. See figure below, the right triangles formed to determine the height of the remote point. This fieldwork will not consider the effects of combined correction of Earth's curvature and refraction. Determine the difference in elevation between two instrument setups. Using the formula, difference in height of instrument equal h sub 1 minus h sub 2. Next, consider triangle BEF, then solve for the distance x using the tangent function. Tangent beta equal to h sub 1 minus h sub 2 all over x. Determine the sum of distance AB and distance x for the analysis of the oblique triangle AFD. Using the formula A prime F equal AB plus x. Now, consider triangle A prime FD and use sine law to determine the distance FD. Using the formula AB plus x all over sine between the difference beta and alpha equal FD all over sine alpha. Consider the triangle FDG and determine the height of the remote point DG. Using the formula sine beta equal h minus h sub 1 all over FD. And that's all. Thank you.